Welcome students. Today we are here to study the subject digital image processing. This is a final year elective paper having the code number EC703A. I am Kaushik Pal, Assistant Professor of Department of Electronics and Communication Engineering, Guru Nanak Institute of Technology. Today's topic is image segmentation. We have studied the basics of image segmentations. We have some ideas about the isolated point, lines, edges, different type of segmentation process, what is segmentation, what is the application, and why we can require this type of applications. This is the outline. We have already gone through the introduction of segmentations, point, line and edge detection techniques, which we have already followed. Now here we should learn different type of thresholding techniques, then watershed segmentation process, after that region based segmentation process, and after that the applications of all these processes. So this class will consist of mainly these three techniques. The first one is thresholding techniques, which is very much important. The next one is watershed segmentation or watershed algorithms. So this is also very important. We can already see that different techniques we have used. This is another type by which we can separate the different areas of an entire image into different subdivisions. The last one is region based segmentations. Here also we can see that from starting a seed points, how we can accumulate all the pixels to form a region, and that particular region being segmented from the entire image. So these three will be discussed here: thresholding technique, watershed segmentation, and region based algorithm technique here. So this is a very important parameters, and this is a very important term in case of this edge detection technique or this segmentation process, which is known as thresholding. So thresholding plays a very important role in case of thresholding. Here we can see some histogram images which is given by here. The first image is the image with dark background and light object, and the right side example of the image is image with dark background and two light objects. So the first image is gray level histogram that can be partitioned by a single threshold, and the second one is the multiple threshold. So it's very clear. The first image have the image with dark background and on a single light image, and the second image has two light objects, so that is denoted by T1 and T2. So here thresholding plays a very important role. So multi-level thresholding also very important. A point xy belongs to an object class of T1, which is the function fxy image functions lies between T1 and T2. To another object classify if fxy must be greater than T2, and to background if fxy is less than equals to T1. So these are the different parameters or different features, and T depends on only fxy, only on gray level values. Global thresholding, both fxy and pxy on gray level values and its neighbors, that means local threshold. So this is the multi-level thresholding process. Now there is a very important role of illuminations in case of this thresholding technique. Here some of the images we can see. The first image use the computer generated this is the reflections functions, and the second one is histogram of these reflectance functions. The third image is the computer generated illumination functions, and the fourth image is the product of A and C, and the last image is the histogram of the product image. So here we can see the two histogram, that means the histogram of the reflection function and the histogram of the product image. So from here we can have the image functions fxy is equals to ixy multiplied by rxy, where xy is the coordinate of that particular pixels or point, and ixy is the amount of incident light, and rxy is the amount of reflected light. So this is the product of the ixy and rxy to find out the fxy. So all the four, here we are having the 5 images. Now all the 5 images are there. The first image is the computer generated reflection functions. The second image is histogram of reflection function. The third one is the computer generated illumination function, which is poor, and the final value is the product of A and C, and the histogram product of the image is given here. So we can see that the last image is very difficult to segment, and the previous image easily use global thresholding object and background are separated. So the second, from the second image or the thresholding image, so that can be easily separated out, but the last image or thresholding image, we can see it is very much difficult for segmentation. Now this is the basic global thresholding values. Use the T midway between the maximum and the minimum gray level. Now generate this binary image. We can see here the 3 images are there. The first one is the original image, the second one is the image histogram, and the third one is result of global thresholding with T midway between the maximum and minimum gray levels. So this is the basic global thresholding. Now moving to the next slide. So this is basic global thresholding. So these are the based on visual inceptions of histogram. So there are some steps are there. The first is select an initial estimate for T. The second step is segment the image using T. This will produce two groups of pixels, G1 consisting of all pixels with gray level values greater than T, and another G2 which consists of pixels with gray level values less than equals to T. The third step is compute the average gray level values mu1 and mu2 for the pixels in regions G1 and G2. The fourth step is compute a new threshold value. The fifth step is T equals to 0.5 multiplied by mu1 plus mu2. We have to choose like that. And the sixth step is repeat step 2 through 4 until the difference in the T in successive iterations is smaller than a predefined parameters T0. So we have to repeat these steps 2 to 4 to until the difference in T is corresponding predefined smaller than a predefined parameters of predefined threshold value T0. So these are the different 6 steps which we have to follow to find out the basic global thresholding. Now this is heuristic methods examples we are seeing here. So here we have to note that the clear valley of the histogram and the effective of the segmentation between the object and background is given. Here T0 is equals to 3 equals to 0 and 3 iterations with the results of T is equals to 125. Here we have the 3 images. The first image is the original image, which is nothing but a fingerprint image, and the second image is the histogram of that particular fingerprint image, and the last one is the result of segmentation with threshold estimate by this iteration process. So this is, we can see the last or the third image is very much clear than the previous image, and this can be easily find out the output and input using the histogram process of the thresholding process. Now there is a very important term which is known as adaptive thresholding. We have learned a little bit about the thresholding. Now we should go for adaptive thresholdings. There are some basic points. We have to subdivide the original image into small areas, utilize a different threshold to segment each sub-images. Since the threshold used for each pixels depends on the locations of the pixels in terms of the sub-images, this type of thresholding is known as adaptive thresholding technique. So these are the basic points for adaptive thresholding process. So this is an examples of adaptive thresholdings. Here we are having the 4 images. So the first one is the original image. The second one is result of global thresholding. If we use the global thresholding, we will have the second image. Now the third image is nothing but the image subdivided into individual sub images, and the last one is results of adaptive thresholding. So we can see using the adaptive thresholding we can find out the corresponding required output. So this is an example of adaptive thresholding, which is very much important. Now this is further subdivisions. So the first one is properly and improperly segmented sub images from previous examples has been given here. So B to C is the corresponding histograms has been given here. Now the fourth image is the further subdivisions of the improperly segmented sub images has been given, and the fifth image is the histogram of the small sub image at the corresponding top values, and the fifth one is results of adaptive segmented values of the D. So here we are having different types of subdivisions, and accordingly we are also see the corresponding thresholding values of this histogram process. Now moving forward to the next topic, which is segmentation by morphological watersheds. So watersheds is a very important parameter which is used for segmentation process. We will discuss about these watersheds algorithm. So here if we move forward the introduction, we can see we can use the corresponding MATLAB functions, which is imshow, and also the maze. We can plot the maze. So this is the based on visualizing an image in 3D. We can see like this. So instead of working on an image itself, this technique is often applied on its gradient image also. In this case, each object is distinguished from the background by its uplifted edges. So this is very interesting. Moving forward to the next slide, we can see some basic definitions. So here I equals to 2D gray level images, D1 equals to domain of I, path P of length I between P, small p and small q in capital I, A corresponding I plus 1 minus tuple of pixels which is denoted by P0 is equals to P, P1 up to corresponding Pi equals to Q, such this Pi such that Pi plus 1 are adjacent. that adjacency may be follow either 4 adjacents, 8 adjacents, or AM adjacency corresponding figure, which we have already discussed earlier. Now here IP equals to the length of the given path P has been given, and which must be minimum. And what do you mean by minimum? A minimum M represented by M of I is a connected corresponding plateau of pixels from which it is impossible to reach a point of lower altitude without having to climb. Now this is, instead of working on an image itself, this technique is often applied to the gradient image. Three types of points are there. So points belonging to a regional minimum. Next one is this is the catchment basin, which is known as watershed of a regional minimum, points at which a drop of water will certainly fall into a single minimum. Now divide line or watershed lines, which is points at which a drop of water will be equally likely to fall to more than one minimum. Now last one is crest lines on this topographic surface. This technique is to identify all the third type of points for segmentation. So in the image we can see that the watershed ridge lines and the catchment basins. So these are the basic steps for watershed algorithm. Here are 4 images we can see very clearly. The first one is pressing holes in each regional minimum of corresponding value L. The 3D tomography is flooded from below gradually. The third is when the rising water is distinct, catchment basins is about to merge, a dam is built to prevent the merging process. So here in other we can see the dam boundaries, we can see which is correspond to the watershed lines to be extended by watershed segmentation algorithm. Eventually only constructed dams can be seen from the above. Here we can see 4 images. The first one is the corresponding we can value the result of further flooding can be seen in the first image. The next one is beginning of merging of water from 2 catchment basins. A short dam was built between them, and the third image is the longer dams, and the fourth image is the final watershed or segmentation lines. So this is an example by which we can see how segmentation can be done using this watershed algorithm process. Moving forward to the next slide. This is the process by which the dam are being constructed. So that is known as dam construction. Based on binary morphological dilation process, we should use this dam construction. At each step of the algorithm, the binary image is obtained in the following manner. The first one is initially the set of pixels with minimum gray levels are 1 and other values are denoted by zeros. In each subsequent steps, we flood the 3D tomography from below, and the pixel covered by the rising water are ones and the others are zeros. So from the previous slides that has been clear to us. So these are the different features by which we can construct the dam. So here we can see some examples. So the M1 and M2 sets of coordinates of points in the 2 regional minimum, Cn-1 of M1 and Cn-1 of N2 is the sets of coordinates of points in catchment basins associated with M1 and M2 at stage n-1 of flooding. This is the catchment basins up to the flooding level. And next Cn-1, which is union of Cn-1, M1, capital M1, and Cn-1 of M2. So all the three sets of images are here, which is being explained here. So three colors has been here, which the color parameters has also been mentioned at the right bottom. Now these next slides, again the dam constructions continued. At flooding step n-1, there are two connected components. At flooding step n, there is only one connected component. This indicates that the water between the two catchment basins has merged at flooding step n. Use Q to denote the single connected components, and then repeatedly dilate Cn-1 of M1 and Cn-1 of M2 by the 3x3 structuring element shown, subject to the following conditions. And this constructed to Q center of the structure element cannot go beyond Q during this dilation process. The next one is the dam is constructed by the points on which the dilation would cause the sets being dilated to merge, resulting 1 pixel thick connected path. Now the next one is setting the gray level at each point in the resultant path to a value greater than the maximum gray value of the image. Usually maximum value plus 1 has been used here. Now this is nothing but the watershed transformation process. Some steps are there, we have to understand them. The first one is denote M1, M2, Mr as a set of the coordinates of the points in the regional minima of an gradient image, which is denoted by Gxy. Then denote Cmi as the coordinates of the points in the catchment basins associated with regional minimum Mi. Then denote the minimum and maximum gray level of Gxy as mean and max. After that, denote Tn as a set of coordinates small st for which G of small st must be less than n. Flood the tomography in integer flood increments from n equals to minimum plus 1 to n is equals to maximum plus 1. At each flooding, the tomography is viewed as the binary image. So these are the several or different criteria for this watershed transform. Moving forward to the next. Now here denote Cn-Mi as a set of coordinates of points in the catchment basins associated with minimum Mi at flooding stage n. So here Cn-Mi equals to Cmi intersection Tn. Cn-Mi is a subset of Tn and denotes Cn as the union of the flooded catchment basins portions at stage n. Cn equals to I equals to 1 to R union of Cn, Mi and C max plus 1 equals to union I equals to 1 to R C Mi. So next initialization, then let C equals to minimum plus 1 equals to T minimum plus 1. At each step n, assume Cn minus 1 has been constructed. The goal is to obtain Cn from Cn minus 1. Now denote Qn as a set of connected components in Tn. For each Q which is corresponding is Qn, there are three possibilities. The first one is Q intersect Cn minus 1 is empty Q1. A new minimum is encountered. Small q is incorporated into Cn minus 1 to form Cn. The next one is Q intersect Cn minus 1 contains one connected components of Cn minus 1 of Qn of Q2. Q is incorporated into Cn minus 1 to form Cn. And the third one is Q intersect Cn minus 1 contains more than one connected components of Cn minus 1 Q3. A ridge separating two or more catchment basins has been encountered. A dam has to be built within Q to prevent overflow between the catchment basins. This process repeat the procedure until n equals to max plus 1. This is the final one. So this is an example by which we can see here A, B, C, D, some images are there. The A images is the original image. The B image is the negative of the image A. The C is distance transform of image B, and the fourth image is the corresponding watershed transform of the image C. So here we can see the corresponding examples which has been given here. This distance transform of a binary image is defined by the distance from every pixel to the nearest non-zero valued pixels. So this is the first examples by which the watershed transformation of a binary image can be seen very clearly. Now if we take another examples, that means moving forward to the next examples. This is examples 2. The first one is the original image. The second image is gradient image of the first image, that means the original image. The third one is watershed lines obtained from the image B, which is known as the over segmentation. Each connected region contains one local minimum in the corresponding gradient image. And the final image, that means the fourth image, the D image, is the watershed lines obtained from smooth images B. So if we smooth the image B, so then we can have the last image, which is the watershed lines obtained from the smooth image B. So this is another example of this watershed algorithm. Here we can see the segmentation process can easily be done using this watershed algorithm process. The use of markers is very important. Internal markers are used to limit the number of regions by specifying the object of interest, like seed in region growing method can be assigned manually or automatically. Regions without markers are allowed to be merged. No dam is to be built. External markers, those pixels we are confident to belong to the background. Watershed lines are typical external markers and they belong to the same background or region. So this is the use of markers here. So watershed based segmentations has been given here. The first is use internal markers to obtain watershed lines or the gradient of the image to be segmented. The next one is use the obtained watershed lines as external markers. The third point is each region defined by the external markers contains a single internal markers and part of the background. The fourth is the problem is reduced to partitioning each region into two parts, object containing internal markers and a single background containing external markers. Here global thresholding, region graying, region splitting and merging or watershed transformations has been given here. So in these images, the first one is image showing internal markers, light gray regions and external markers which is watershed lines. The next image is result of segmentation process. So here we can see the image has been segmented very precisely. So this is nothing but one example watershed based image segmentation process. So here one MATLAB examples has been given. So by these MATLAB examples we can have all these images. So here we can have all the 7 images. So these 7 images can be derived by these corresponding all the images using the MATLAB functions. So this is an example of these MATLAB functions. So all the images has been given here. So first one is the A image is the original image which is represented by F. The B is direct watershed transform result using the following commands. L is equals to watershed of G, W R equals to L equals to which is 0. G is the gradient of the image A, and the C image, that means the third image, shows all the regional minima of G using Rm equals to these values, and the value is Im regional minimum of G. The D images, that means the fourth images, is the internal markers obtained by the corresponding functions. Im equals to Im extended mean G2, Fim equals to Fim of Im equals to 175. The value has been given here. E is the external markers using the corresponding L minimum watershed, BW distance of Im. So Em equals to L minimum equals to 0. The fourth one is the modified gradient image obtained from the internal and external image, and the last one is the final segmentation results. So here all the MATLAB functions which have been used to find out all the images has been given. The first image is the original image. The second image is the direct watershed transform result using the corresponding watershed algorithm. The third image shows all the regional minima of G using the corresponding command. The fourth image is the internal markers obtained by the command has been also given, and all the images are been given, and the final segmentation result is represented in G. So this is another examples which we have already discussed. Now we should move forward another new topic which is known as region based segmentation, which is also known as region graying. So region based segmentation is also very much important. So from the term region, this is very common that some area may be there. So region means some area which is having the pixels with similar values. So region based segmentation is another type of segmentations which is very important, and among them region graying algorithm is there, or region graying segmentation process is very important. So from here we have to keep in mind a very important point which is known as seed point. So seed point is a very important parameter from where we have to start. So seed nothing but pixels which we have to choose from where we will move or we will start. So that's why start with a set of seed points, then growing by appending to each seeds those neighbors that have similar properties such as specific ranges of gray levels. That means a particular point or particular pixels may be treated as seed points, and that particular pixels will be compared with its neighbor pixels. That may be either 4 neighbor pixels or 8 neighbor pixels. Those pixels, if they have the similar gray level values, they will be accumulated together by forming some regions, and by this process, if we follow or if we repeat this process, gradually the region will be increased and the area will be enhanced. So this is nothing but the region algorithm. So this region growing algorithm, here we have select all seed points with gray level 255. So this is an example. This is the criteria, 2 criteria has been given here and the 4 images has been also given here. So we will discuss about this. The first criteria is the absolute gray level difference between any pixels and the seed has to be less than 65, and the second criteria is the pixels has to be 8 connected to at least 1 pixels in the region if more regions are marked here. So here the first image is shown the corresponding defective wells. The next image is we have been taken as seed points, and the third image is result of region growing algorithm, and the corresponding fourth images is boundaries of segmented using the segmented algorithms of the defective wells has been here. So all the defective regions has been segmented or separated out from the first image using these region growing algorithm techniques. Now region-based segmentations, we have to discuss some process. The first one is region growing groups of pixels or sub-regions into larger regions. The definitions has been given here and some steps we have to mention. The step 1 is start with a set of seed points and from these grow regions by appending to each seed those neighboring pixels that have properties similar to that particular seed point. The step 2 is region splitting and merging process. Now this is known as the advantages is with good connectivity, and the disadvantage is initial seed points. Different sets of initial seed point cause different segmented results, and this is also time consuming problem. So these are the several advantages and disadvantages of region based segmentation algorithms. So unseeded region growing algorithm may be also be possible. So that is also categorized under region based segmentation, which is here unseeded region growing. No explicit seed selections is necessary here. The seeds can be generated by the segmentation procedure automatically. It is similar to SRG except the corresponding choice of the seed point. Now the advantage of this USRG, that means these seed points should not be choose precisely. Now the advantages is easy to use, can readily incorporate high level knowledge of the image composition through region thresholds, and the main disadvantage is it's very slow or slow speed. Now this is the first scanning. So first scanning algorithms is here. The first scanning algorithm uses some masks. So the first scanning algorithm somewhat resembles unseeded region growing algorithm. The number of clusters of both two algorithms would not be decided before image passing through them. So here some of the examples has been given for first scanning, which is given by different, which is mentioned by different colors, and this is the last step. Of course, after having all the regions, merge small regions to big regions. So this is some of the advantages and disadvantages also given here. The advantages, the speed is very fast for this case. The results of segmentation will be intact with good connectivity, but the disadvantages are the matching of physical object is not good at all. It can be improved by morphology and geometric mathematics techniques. So these all about the segmentation process. We have studied different type of segmentation process by which we can easily understand that how we can detect some isolated point. We have detected some lines, we have also detected some edges. So we have also discussed what do we mean by different isolated points, lines and edges. After that we have used thresholding process by which we can easily done the segmentation process. Then after thresholding we have studied the watershed algorithm, then the region graying algorithm for segmentation process. So these are all about the different segmentation process. So hope students you have understood. So if you have any queries, either you can mail me or you can call me. My mobile number and email address has been given here. Thank you very much for understanding.